Okay, this video is on pyramids, and a pyramid is just a polyhedron with one base. All the sides are triangles, and all the sides intersect at a point. And that point is called the vertex. So you can see on these three pyramids here in your notes, this is a vertex, this is the vertex, and this is the vertex. That's the point where all of the sides intersect. And the pyramids are named according to the shape of their base. So I can see this one is going to be a rectangular pyramid. Its base is rectangular. This one is going to be a hexagonal pyramid. Its base is a hexagon. And this one is going to be a triangular pyramid. Its base is a triangle, triangular. And now I want to make a few notes about what we're going to call regular pyramids. Those are the kinds of pyramids that we're going to be studying. A regular pyramid has a base that is a regular polygon. So all of these bases are regular polygons, a regular triangle, a regular hexagon, a regular rectangle. So technically this would be a square pyramid, since all four sides of the bases are going to have the same length. All of the sides are not just triangles, but they are specifically congruent isosceles triangles. And we're going to see that's going to come in very handy when we go about calculating the base area, lateral area, total area, and volume. So let's take a look at how we're going to do that with these three pyramids that we have in our notes. So example number one says find the base area of the following pyramids. The base area just means the area of the base. Specifically, notice that for a pyramid we just have one base. So in examples number 1A and 1B, I can see that the base of both of those pyramids is just a square, which means it's just going to be little b base times height. So for example 1A, my base is 8, height 8, that's going to be 64. Example 1B, the area of my base is going to be 10 times 10, which is 100. And let's see my units here. 1A, that's in meters squared. 1B, that is in inches squared. All right, so that was fairly straightforward. When I've got a square pyramid, my base is a square, so that's fairly easy to calculate. In example 1C, I've got a hexagonal pyramid, so I have to calculate the area of my hexagonal base. Well, in this case, because of the information that I'm given, let me go ahead and draw out my hexagon here. And I know that in order to calculate the area of my hexagon, I would like to calculate the area of this triangle. And so let me go ahead and also draw out just that triangle. I know it's going to be an isosceles triangle. And I know that the base of my isosceles triangle is 5 feet, because that's given to me in the picture. And I also know that the apothem of my hexagon, that is the height of this triangle, is 4.33 feet. So I know the base of the triangle and I know the height of the triangle, so I can calculate the area of this triangle. So the area of my triangle is going to be 1/2 times, say 1/2 little b base times height. And I know the base of my triangle is 5 feet. And I know the height of my triangle is 4.33 feet. So if I just multiply these numbers out, then I punch these in on my calculator and I get 10.825 square feet. Now notice that's not the area of my hexagon, that's just the area of my isosceles triangle here inside the hexagon. And in order to find the area of my hexagon, I need to multiply that number times 6 because I have 6 triangles in my hexagon. So 10.825 times 6. And if I punch that into my calculator, I get 64.95. And let's see, this is going to be in square feet. And so this is the base area of my hexagonal pyramid. All right, now let's take a look at lateral area. Lateral area is just the area of all of the sides of a pyramid, and all of my sides are always going to be triangles, so I'm just calculating the area of a triangle. Now, one of the things that, there's a term that we want to introduce here. Since I'm going to be finding the area of each one of these side triangles, and let me go ahead and draw out one of these side triangles over here. I'm going to need not only the base of the side triangle, I'm also going to need the height of the triangle. And notice if I draw that height in on, say, this side triangle right here, that's going to be a line that looks something like this. That is a line that's perpendicular. It goes from up here to the vertex down the side of the triangle and is perpendicular to the base. And we're going to call that the slant height. All right, so the slant height is this line here, which goes from the vertex down the side of the triangle. And I've kind of drawn that here on, here's my three-dimensional pyramid. And I don't know if you can see it, but I've kind of drawn that dotted line down the face, down that one side of that pyramid. That's the slant height on this pyramid. So in order to calculate the area of a side, I need to know the base, which is this distance here, and I need to know my slant height. So let's take a look at our examples. Example number 2a, and again, this is the same pyramid that we had in example 1a. Well, I know, let me draw my triangle out here. I know that the length of the little b base on this triangle is 8. That's given to me in the picture. I also know the length of my slant height. It is 6, because that's given to me as well. Well, since I know the base and I know the height, I can calculate the area of one of the side triangles in my pyramid. So the area of that triangle is 1/2 little b, which is 8, h, which is 6, and that's 1/2 times 48. That's going to be 24. And this area 24, notice, is the area of one of my 4 sides on this triangle. So if I want the entire lateral area, I want the area of all sides, I need to multiply this number times 4. And 24 times 4 is 96. And let's see, that's going to be in meters squared. So my lateral area for 2A is going to be 96 square meters. All right, now in example 2b, notice in this one, I'm not actually given the value of the slant height of my triangle, so I'm going to have to figure out what the slant height is. The value that I'm actually given is this value over here, which is the edge of that pyramid. I'm given the edge height. Well, I can use that to find what my slant height is. And in fact, since I know what the edge height is, let me draw one of my side triangles here. I'm told that the edge is 13. That's this side right here. I also know that the base is 10. And I'm trying to find my slant height. Let me call this S for slant height. That's my slant height. That's the height of my side triangle here. Well, notice that I've got a right triangle here. I know that the hypotenuse is 13. I know that this piece of it is 5 because it's half of this whole triangle. And I'm looking for S. Well, I can use the Pythagorean theorem to find out what S is. So let's see. S squared plus 5 squared equals 13 squared. So S squared plus 25 equals 169. S squared equals, subtract 25 from both sides, that gives me 144, and S then equals 12. Now I know what my slant height is. Now I can calculate the area of my triangle. So let's see, area of triangle is going to be 1/2 times the base, which is 10, times the slant height, which is 12. And that's going to give me 1/2 times 10 times 12. Let's see, that's going to be 60. And once again, the lateral area, I want the area of all the sides. This is the area of just one side. Since it is a square pyramid, I have 4 sides, so I want to multiply this times 4. And that gives me 240 square inches. And that is the lateral area. All right, now in 1C, I have a hexagonal pyramid, which means I've got a total of 6 triangles. And yet, once again, let me do this one up here. Once again, I have a side triangle here. It's an isosceles triangle. I know from my picture that the base is 5 feet. And I'm also told the slant height for my pyramid. My slant height in this case is 10. So I have enough information here given to me in the picture to calculate the area of one of the sides of my pyramid. All I need is, it's going to be the area of this triangle, 1/2 little b base times height. So let's see, 1/2, my base is 5. My height, that is the slant height of my pyramid, is 10. So that's 1/2 times 50, which is 25. So 25, again, is the area of one of my side triangles. I've got 6 of them, so I multiply that times 6. And that gives me 150 square feet. And that is my lateral area. Total area. As before, total area is fairly simple calculation. You just have to add up the base area and the lateral area. Well, we've already calculated base area and lateral area for these 3 figures, so we just need to fill those in. Let's see, the base area for the first one is 64. The lateral area for the first one is 96. I add those together and I get 160 square meters. That's my total area. Let's see, for B, my base area is 100. My lateral area is 240. So I add those together and I get 340. And that is square inches. And let's see, finally, my hexagonal pyramid. My base area is 64.95. My lateral area is 150 feet squared. And let's see, I add those up and I get 214, and this is in square feet. All right, now let's go on to look at volume. So the volume of a pyramid, if you recall, the volume of a prism, we have a formula that's just big B times H, right? The base area of the prism times the height of the prism. Well, the volume formula for a pyramid, you can see it's not going to be the same as for a prism, because if we just took the area of the base and multiplied it times the height, then we'd get the volume of a prism. Well, it's actually fairly similar though, the formula. The volume is going to be less than the volume of a prism, since we don't have the whole prism shape. And it turns out it's going to be 1/3 of big B times H. That is, you calculate the base area of your pyramid, which we've already done for these 3 pyramids. And then you need something called the height of the pyramid. So this big B here, this is base area of your pyramid, and this is the height of the pyramid. And the height of the pyramid is a line that goes from the vertex of the pyramid down to the center of the base, and it's perpendicular to the base. So this line here, we're going to call that h, the height of the pyramid. So once you have those two values, you just plug them into the formula and you calculate your volume. So let's see how we go about doing that for these three examples. So the volume of our pyramid here for 4A, it's going to be 1/3 big B, area of the base, times height. And let's see. I know the value of big B, the base of this one, because I calculated it back in example number 1. That's just 64. And in this case, I'm given the value of the height. It's in the picture. It's 5. So I just need 1/3 times 64 times 5. And if I multiply those numbers out, then I get 64 times 5 times 1/3. I get 106.67. And let's see, this is going to be in meters cubed. All right, so that was fairly easy. I was basically given all my numbers, right? I'd already calculated the base area and I had the height given to me in my picture. Let's take a look at these last two examples. Example 4B. Now, example 4B, I've got another square pyramid, and I also already know the value of my base area because I calculated it back in example number 1. So my base area is 100. But notice I don't have this value here for the height of my pyramid. Well, it turns out that I can figure out this value, but in order to do that, I need to be able to see that there's a particular right triangle in here that's going to help me, and that is this right triangle right here. And notice this is a right triangle here made up of the height of the pyramid, half of the length of the base of the pyramid, and the slant height. So I'm going to take this triangle here. Let me draw this out over here. This right triangle, this is the height of my pyramid. That's what I'm looking for. This is half of the length of the base, and I know that because my base length is 10 inches, so this length here is 5. And I actually also know the slant height because I calculated that back when I was doing the lateral area. So the slant height of this pyramid is 12. Well, I've got a right triangle. I know 2 of the sides of the right triangle, and I can use my Pythagorean theorem to calculate h. So let's see, h squared plus 20 plus, let's go ahead and say 5 squared equals 12 squared. H squared plus 25 equals 144. H squared equals 119. So h equals the square root of 119, which is 10.91. So now I know h, which is the height of my pyramid, and I can plug that in here, 10.91. And now I can calculate the volume of my pyramid, which is 363.62, and this is in cubic inches. Okay, finally, I want to calculate the volume of my hexagonal pyramid. Again, I've already calculated the base area. I did that back in example number 1. Let's see, my base area is, what's the base area for my hexagonal pyramid? 64.95. So now I just need the height of my pyramid, which is this line here. Now on this one, I can see I also have this value here, which is the apothem for my hexagon. I can see that value is 4.33 feet. And now once again, I have this right triangle inside my pyramid, which is made up of the height of my pyramid, this line here that goes to the midpoint of one of my sides, and then my slant height. So again, let me take this triangle here and break it out. This is the height of my pyramid. That's what I'm looking for over here. This value here, that's this line here, which I'm told is 4.33 feet. So this is 4.33 feet. And this is my slant height. And once again, I calculated the slant height of my hexagonal pyramid over here in example number 3. Let's see, my slant height was, or rather I was given that value. That slant height is 10. I'm given that in the picture. So now I have enough that I can calculate my value of h using the Pythagorean theorem. So h squared plus 4.33 squared equals 10 squared. Now I just need to solve my Pythagorean theorem. 4.33 squared is 18.75 equals 100. Subtract 18.75 from both sides, and I get h squared equals 81.25, and the square root of each of those, and I get h is 9.01, and again I plug that in here, and I find that my volume is 195.15 cubic feet.